Hello, class. I'm going to go over the notes for section 3.1 of chapter 3. We're beginning our lesson on parallel and perpendicular lines. Okay. As always, you can look up this information in the Big Ideas textbook and find examples as well. So I gave you a live link right here. If you click the link, it'll take you to Clever, where you can go to Big Ideas. So in this section, our learning goals is to identify lines and planes, parallel and perpendicular lines, and pair of angles formed by transversals. This section starts on page 126 of the Big Ideas textbook. So it's important to know what parallel lines are. Parallel lines are lines that will never intersect. So let me change screens for a second. On your screen, on your slide, you can either click in here and then type what are parallel lines you want to type in. They are lines that are on the same plane but never intersect. Or you can add a text box. So a text box, if you go up here to text box, click it, and then click where you want your text box. And it doesn't have to be this big, so you can make it smaller. See what I just did? You can move it around. Oopsie. Where's my text box go? This text box. So you can move it around, make it smaller, okay? And then you can add another text box for all of these other questions. So it's important to know that parallel lines do not intersect, and they are also coplanar. So I'm going to highlight that part because that's very important. They do not intersect, and they are also coplanar. Remember what coplanar means. That means they are on the same plane. So I'm going to put that on same plane. If they're on the same plane, think of both lines being on the same flat surface. So it's hard for me to show you when you can't see me. But think of if you had two lines and they're both on a sheet of paper, okay? Like so. Oops, they don't look parallel. But they're both on the same sheet of paper and they don't intersect. Those are parallel lines, okay? They go in the same direction. Now, skew lines also do not intersect. However, they are not coplanar. So that means they are on different planes. So not coplanar, that means on different planes. If they're on different planes, then they kind of go in different directions. Okay, so imagine if my example up here, you got a sheet of paper like this. So imagine you have one line that's on the paper, like so. And then you have another line, and let's say your other line is not on the paper. It's like in front of the paper. So it's hard for me to draw it because it looks like it's on the paper. Okay, so I can't really show you in a drawing, or maybe it's over here somewhere. Okay, going in a different direction. Those are skew lines. See how these two lines, they are not going to intersect because this is off of the paper and this is on the paper. Okay. So in this example right here in your book, on your slides, which lines are parallel? Line M is parallel to N. And notice I use the symbol for parallel to. Okay, so in the slides, I think it says, where is it? Right here. Make that bigger, full screen. So this symbol, that's those two lines right there, it means it's parallel to. So I'm not going to write out the word parallel. Also on the diagram, pay attention to the little arrows, the little red arrow marks, these right here. Anytime you see that in a diagram, that indicates that you have lines that are parallel. So line M is parallel to N. They do not intersect. They are both lying on the same plane, on plane T. So think of plane T as like your flat sheet of paper, and both lines M and N are laying on it. So they are parallel, okay? So Those are parallel lines. For skew lines, so line K does not intersect line M, and they are not on the same plane. Those lines are skew lines. So I want to explain. So look at line K. Now see how once it gets to this point it's dotted. So think of K as going through the sheet of paper, right? Like if you poke a hole through a sheet of paper and then stick your pencil in it, that's what line K is doing. It's going through the plane or through that sheet of paper, while line M is laying on the paper. So line K is not intersecting line M because it's like in front of it going through the paper. Okay, so these are skew lines. So let's look at this box and we're going to determine which lines are parallel or perpendicular or skewed to line FG. So here's line FG, okay? So skew lines, that's a line that does not touch FG. We're going in a different direction, okay? So you could say CH. You could say CH is skewed to line FG. See how line CH is underneath it? If it's underneath it, it's never going to cross it, okay? Like CH is on the bottom of the box, while line FG is at the top of the box. So those two lines will never cross. So far we have CH, okay? Also, you could have said DE. Okay, DE is also on the bottom of the box and FG is at the top. So those lines will never intersect. So DE. And I'll give you one more, even though there's more than that. How about AD? So again, AD is in the front of the box. See that? And FG is in the back of the box. So line AD is also skewed to line FG. Perpendicular lines. So let me erase this. Erase this. Perpendicular lines have to meet and make a right angle. Okay? So they got to touch each other. Any line perpendicular to FG, that means it has to touch FG at a right angle. So in the diagram, I'm looking at the squares. Okay? And I see that AF is touching FG and making that square. See this square right here? Okay. So AF is perpendicular to FG. AF. And I also see BG. BG is making a square with line FG. So BG is perpendicular to FG. Okay. Which lines are parallel to FG? So if you look at line AB, see how they both go in the same direction and they're both laying on the same plane. This plane right here, the top of the box. They're both on the top of the box. See that? So AB is parallel to FG. Also, so let me erase some of this stuff here. So check out line EH down here. EH is also parallel to FG. They are both laying on the same plane. The plane that they're on is the back of the box. See that? This plane right here. So they're both laying on the same plane, which is the back panel of the box. Okay? All right, let's move on. Boom. Scroll down. Pairs of angles. So you need to know that a transversal is a line that intersects two or more lines at different points. Basically, if a line crosses another line, it's a transversal. I mean, if a line crosses another two lines, it's a transversal. Hopefully on this page, you added the answers to your notes that we just went over. Okay? So, let me go back to this page. So right here, line P is the transversal. So line P, that's the transversal. Interior versus exterior. I did not put that in your slides, but you ought to add them because this is important. So when we're talking about interior angles, we're talking about angles that are between the two parallel lines, like in this area. So this area right here is the interior, okay? In between the two parallel lines are interior. So that area is interior. Outside of the parallel lines is exterior. All of this up here and all of this down here, that's exterior. And that's important. So that's exterior. It was hard for me to write on here. And that's also exterior. Okay. So when we talk about angles formed by transversals, it's very important for you to know these angles when you see them because we're going to be doing a lot with these angles. So here I have a diagram of two lines intersected by a transversal. Line T is a transversal. We got 8 angles in the picture. Corresponding angles. Your book says when they have corresponding positions, then they are corresponding angles. Okay? What do you mean, Miss Speight? Well, I'm going to give you more information also. Not only do they have corresponding positions, so I'm going to type down here. So one angle is going to be on the interior, the other on the exterior. Okay, let me make that smaller. So one angle will be interior, the other will be exterior. Dang it. Didn't mean to do that. Okay, stop. Crap. All right. And they are in the same position. What I do? Okay, there we go. So same position. What you mean, Miss Speight? I'm glad you asked. So peep this. All right. So right here, look at this intersection. Okay. Angle 2 is at the top right corner of that intersection. Okay. Now, if I go down to the bottom line and look at that intersection, which angle is in the same position as angle 2? Angle 6 is also in the top right corner. Okay, so angle 2 and angle 6 are corresponding angles. Let me write that down. Angle 2 and 6 are corresponding angles. What else are corresponding angles? Well, you got angle 1 and angle 5. They are both in the top left corner. They're in the same position. So 1 and 5 are corresponding angles. Also, angle 3 and angle 7 are corresponding angles. They are in the same position. They are both in the bottom left corner of the intersection. Think of the intersection as like a plus sign. You feel me? So angle 3 is in the bottom left corner, and so is angle 7. And finally, we have angle 4 and angle 8 are also corresponding angles. They are in the same position. They're in the bottom right corner. Okay? Now, what was I saying earlier about one is on the interior and one is on the exterior? All right, so let me use my crayon, yellow. So the yellow part is interior, okay? So when I said angle 2 and 6 are corresponding angles, notice that angle 6 is on the interior and angle 2 is on the exterior. See that? 1 and 5 are corresponding. Angle 1 is on the interior. 1 is exterior, 5 is interior. Same with the other 3, okay? But they have to be on the same side of the transversal. So I'm going to add that as well. They have to be on the same side, of the transversal. Okay? They're on the same side of the transversal. One is on the interior, one is on the exterior. And I got one more little nugget for y'all. So I'm a visual person. Ooh, dang, I'm going to erase this. I'm a visual person. So when I see corresponding angles, such as let's say angle 4, here's angle 4, and angle 8. Here's angle 8. When I trace corresponding angles, I see the letter F. Do you see it? So when I look for corresponding angles, I look for two angles that make the F. One angle is in the F, and one angle is like right up underneath it, like that. So I'm also going to add that they make an F. They make an F. All of that is for corresponding angles. Okay? On this, one angle is on the interior, one is on the exterior. They're on the same side of the transversal. They make an F. Or your book said they have corresponding positions. They're in the same spot. So corresponding positions, that means same spot. Okay. Next, we have alternate exterior angles. Okay. Your book says they lie between the two lines, so that means they're both on the interior, but on opposite sides of the transversal. So let me highlight opposite sides of the transversal. They lie between the two lines. What do you mean between the two lines, Miss Speight? That means on the interior. Okay, so they got to be somewhere in this region. Oh, I didn't want that color. They have to be somewhere on the interior, right? But they're on opposite sides. I also added that they do not share a vertex. This is important. I said the same thing about corresponding angles. Do not share a vertex. So you're going to pick two angles on the interior, but on opposite sides of the transversal, and they don't have the same vertex. Hopefully you are coming up with angle 3 and angle 6. See how angle 3's vertex is up here. Angle 6 vertex is down here. See how they're on opposite sides of the transversal? One is on the left, one is on the right. They're both on the interior because they're both in the yellow region. Okay, so far we have angle 3 and angle 6. Angle 3 and 6. And also, you should have seen angle 4 and angle 5. Angle 4 and angle 5 are also alternate interior angles. Angle 4 and 5. So let me type what I just said. I already put they do not share a vertex. They are both on the interior. So both on the interior. Okay. Different vertex. They're on opposite sides of the transversal. Put that there. On opposite sides of the transversal. For your alternate interior angles. And again, I have another nugget for y'all. So let me do this one more time and erase. So when I trace my alternate interior angles, so check out angle 3 and angle 6. When I trace trace alternate interior angles, I see a Z. Your Z can be backwards, upside down, or sideways. But for me, every time I find alternate interior angles, I look for the Z. And those angles that are alternate interior are in the corners of the Z, like that, right here and here. Okay? So I'm going to add that also, is that they make a Z. They make a Z. That's for their alternate interior angles. Okay? Moving on. Hope you're typing this on your slides. Alternate exterior angles. Okay? Notice the word exterior. So they're not on the interior, they're on the exterior. That means they got to be on the outside of the two lines. So let me use my crayon. So they're in this region. They're either up here or down here, but they do not share a vertex. Okay? Emphasize that. They do not share a vertex. They're on opposite sides of the transversal. Opposite sides do not have the same vertex. Got to be on the exterior. So that would be angle 1 and angle 8 are alternate exterior angles, angle 1 and 8. Also, angle 2 and 7 are alternate exterior angles. Alternate means they kind of switch, like switch sides. You feel me? And exterior is on the outside. So every time you hear the word alternate, think switch sides of the transversal. Okay? Now, the only little nugget I could come up with, I couldn't really come up with nothing. But one student has said to me, this was years ago, well, Miss Speight, they kind of look like L's that are separated and going opposite directions. Like this and like this. So I'm like, okay, cool. Another person told me they kind of look like an X that got taken apart. I said, oh, that was kind of cool. Because if I were to put this, it won't let me move it. Let me draw another one. Let's see. All right, let me try to move it. So if I were to take this L and put it here, see that? Together would make an X. So think of the X that got separated. A separated X. I don't know. I try to come up with nifty things for my visual learners. Last one are your consecutive interior angles. Consecutive, that means same side. So alternate means they switch sides of the transversal. But consecutive, that means they are on the same side of the transversal. But again, they do not share a vertex. So same side of the transversal, but they do not share a vertex. Also, pay attention to the word interior. So they got to be on the interior of the two lines. So again, we're looking in this region right here. Okay, so two angles on the same side of the transversal and on the interior, but they do not have the same vertex. You should be looking at angle 4 and angle 6. Angle 4 and 6. Also, angle 3 and 5 are consecutive interior angles. Okay, when I trace angle 3 and 5 and angle 4 and 6, so to me, they look like a square C. Okay, so I'm going to put that as a little nugget, that they make a square C. The consecutive interior, they make the square C. So let's review. Corresponding angles. So they're corresponding. That means they're in the same spot or the same position. One angle will be interior, one is exterior. They're on the same side of the transversal. Together, they kind of make an F. So I'll be looking for angles inside of an F. Alternate interior, they alternate. That means they are on different sides of your transversal. They're both on the interior. So that's this region in between the lines. But they're on opposite sides of the transversal. They do not have the same vertex. When I traced them, I saw a Z. So look for the Z angles that are in the corners. So I said all that here. Alternate exterior, they alternate. So that means they're on opposite sides of the transversal. They're on the exterior. So not in between the two lines, but outside of the two lines. They do not share a vertex. They kind of make L's that don't touch, or you could say an X that got taken apart. So an X that got taken apart. All right. And consecutive interior. Consecutive meaning same side. Interior means in between the two lines. They do not have the same vertex. Together, I see a square C. Angle 4 and 6, angle 3 and 5. Please do not confuse the angles made by a transversal with the ones we learned from chapter 1. Linear pairs, they do have the same vertex, okay? So that's important. Same vertex for linear pairs. Right next to each other, they are adjacent. Their other two sides form a straight line. Also, vertical angles have the same vertex. And they do make the X. So not an X that got taken apart and the X that's together. Vertical angles are across from each other. okay, with the same vertex. So let's see how you do with identifying different types of angles. So let's see, you should be on, what slide are we on now? Ooh, this is slide, what is it? Slide 9. Okay, so the first thing I like to do is I identify my transversal. So here's my transversal here. And then the interior, I'm going to color that in. So my two lines are here and here. So that means all of this yellow part is the interior. Okay. So corresponding angles. Corresponding angles have to be on the same side of the transversal. One is interior, one is exterior. They're in the same position. So you should have angle 1 and 5 are corresponding angles. Also, angle 2 and 6. Also, angle 3 and 7. And finally, angles 4 and 8 are corresponding angles. They're in the same spot. 1 and 5. So angle 1 is in the top left corner of the intersection, and angle 5 is in the top left corner. If you're looking for the F, so here's angle 5, and here's angle 1. So I see a sideways F. Okay? All right. Alternate interior angles. Remember, they alternate, so they're on different sides of the transversal, so different sides of the purple line. They've got to be on the interior. They do not have the same vertex. Okay? So if I look at angle 2 and then angle 7, they're on opposite sides of the transversal, but they do not have the same vertex. So alternate interior would be angle 2 and 7. Also, angle 4 and 5 are alternate interior angles. Angle 4 and 5. Remember, they do not have the same vertex. And if you like my Z method, here's my Z. So angle 4 and 5 are in the corners of the Z. And then my green Z, see the green Z? Right there. So angle 2 and 7 are in the corners of the Z. Okay, get rid of that. Uh-oh, what'd I do? Undo. Undo. Ah, dang it. Let me write it again. Okay, so we said angle 4 and 5, and also angle 2 and 7 are alternate interior angles. Alternate exterior. So exterior is not in the yellow region. The yellow region is the interior. So we looking at 1, 3, 6, 8 are all on the exterior, but they're alternate. That means on different sides of the transversal, but they cannot have the same vertex. So if I look at angle 1, on the opposite side, not angle 3, angle 1 and 3 have the same vertex, but angle 1 and 8 do not have the same vertex. So angle 1 and angle 8 are alternate exterior. Also, angles 3 and angle 6 are alternate exterior. They kind of make an X that got taken apart. See that? 1, 3 and 6, and also 1 and 8. Oops. Boom. Okay, consecutive interior. Consecutive means same side. They both got to be on the interior, but remember, they do not have the same vertex. So on the same side, so angle 4 is on the interior, and another angle that's on the same side of the transversal is angle 7. Angle 4 and 7 are consecutive interior. Also, angles 2 and 5 are consecutive interior angles. And remember, consecutive interior angle makes the square C. So here's angle 4, here's angle 7. See, the square C is sideways, okay? Same thing with angle 2 and angle 5. There's angle 2, there's angle 5. Square C. Okay, and I added something. So suppose angle 1 is 93 degrees. So here go angle 1. And suppose angle 1 right here is 93. Find as many other angles as you can. Well, you should notice that angle 1 and angle 2 make a linear pair. See that? Linear pairs, remember, they're adjacent back-to-back angles, share the wall, and make a straight line. So that means angle 2 has to be 180 minus 93, because linear pairs add up to 180. So angle 2 got to be 87. Okay? Now, angle 3. So one way you could look at it, you could say, well, angle 1 and angle 3 also make a linear pair because they are adjacent angles. They're back to back, and they make this straight line. So angle 1 and 3 got to add up to 180. So 180 minus 93 is 87. So angle 3 is 87. But if you remember what I told you about vertical angles, 2 and 3 are vertical angles, which are angles that with the same vertex right across from each other inside of an X. Vertical angles are always congruent. So since angle 2 is 87, so is angle 3. And finally, angle 4 is 93. So you could say because it makes a vertical angle with angle 1 and 4 are the same. Or you could look at angle 3 and 4. They make a linear pair, so they got to add up to 180. Okay? Now, these angles over here, we do not have enough information to say what they are. And the reason why is because these two lines are not matching lines. They're not parallel. They don't slant the same. But we will learn further in the chapter that when you have parallel lines, that means they slant the same. They're like twins. So then with parallel lines, these 4 angles would have been the same as these 4 angles. Okay? But since these lines are not parallel, we can't say anything about angles 5, 6, 7, or 8. But in the future, our two lines, when they're parallel, you'll be able to say, oh, these 4 are the same as these 4. And it's going to be so much fun. So that's it for those angles. And yep, so that's it for these notes. Make sure you send me a message if you have questions, and I will talk to y'all later.